Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to organic chemistry class. In this class we shall discuss the chemical reactions of aldehydes and ketones. We have already discussed the physical properties of aldehydes and ketones and how they are prepared. Now coming towards the chemical reactions that are shown by aldehydes and ketone, let me start from the nature of the carbonyl group and some feature that we discuss some feature of the carbonyl group. If we look at the carbonyl group, it is clear that carbon and oxygen, these are linked together by a double bond. The electronegativity of oxygen is more than carbon, so the shared pair of electron will be attracted by the oxygen and a partial positive negative charge is created over the oxygen while a partial positive charge is created over the carbon. Now there is double bond, but besides the double bond there is electronegativity difference. That's why this group is quite polar. Now although double bonds require more energy to break than a single bond, compounds with double bond tend to be more reactive as addition reaction are possible. Some of the chemical properties of aldehydes and ketones result from the polar nature of the carbon-oxygen bond. Due to this polar nature, carbonyl compounds undergo following three types of reactions. Look at this group. Nucleophilic addition, reduction, and oxidation. The positive charge on the carbon atom makes it open to attack by nucleophile. This part of the molecule is electron deficient. Nucleophile is a species which contain extra electron. It may be negatively charged species or it may be any species with lone pair of electron. So that extra electron is easily be given to this carbon atom, which acts as a carbocation. That's why a nucleophilic addition is possible at this point. So the positive charge on the carbon atom makes it open to attack by a nucleophile. Aldehydes and ketones can be reduced, forming primary and secondary alcohols respectively. Aldehydes are converted usually into primary alcohol, while ketones are converted into secondary alcohols. The reaction is known as reduction. Various reducing agents are used to convert carbonyl compounds into alcohols. And the next characteristic reaction of aldehydes and ketones are oxidation, especially aldehydes. Aldehydes are easily oxidized into carboxylic acid. However, ketones need vigorous condition. So these are three major reactions that are shown by aldehydes and ketone. First one, nucleophilic addition. Second one, reduction. And the third one, oxidation. Nucleophilic addition, reduction, and oxidation. Look at this. This is aldehyde and ketone. If we start from the aldehyde and ketone can be reduced into alcohol. Aldehyde and ketone can also be reduced into corresponding alkane. Similarly, aldehyde and ketones can be oxidized into carboxylic acid, and aldehyde and ketones undergo nucleophilic addition reaction which give an addition product. So most of the reaction of aldehydes and ketone are the three major type of reaction which are shown by aldehyde and ketones are reduction, oxidation, and nucleophilic addition. Reduction into alcohol, reduction into alkane, oxidation into carboxylic acid, while nucleophilic addition has various examples which will be discussed. Now, how the nucleophilic addition is going on? Look at this carbonyl group. partial negative charge, partial positive charge. Z is a nucleophile. So Z will approach to the electron deficient site and Y will be attached there, and thus the nucleophilic addition is happened. You see the mechanism of this due to the polar nature of this one. Oxygen will attract the shared pair electron towards itself, and as a result, if this is complete transfer of electron, the negative charge will be created here, and electronucleophile will approach here, will be attacked here. This is rate determining step, slow step. Now, if nucleophilic addition to a carbonyl group occur in acidic condition, how it goes? Look at this. Oxygen contains lone pair of electron. The lone pair of electron is utilized to capture a proton, and thus OH positive is now present here, linked to carbon. In the next step, the nucleophile will come. The positive charge over the oxygen will be neutralized as this pair will be shifted there, and you see OH is now produced while the nucleophile is attached to the carbonium ion. Now in the next step, if it release the proton, so a neutral species will be formed and proton will be given as it was utilized in the positive. These are certain reactions: oxidation, reduction, then addition of cyanide. These are nucleophilic addition reactions. Addition of cyanide, addition of derivatives of ammonia, amine preparation. We can, by adding ammonia into carbonyl compound, we can get amine. Then addition of alcohols. One special reaction is Cannizzaro reaction, and addition of Grignard reagent. Aldol condensation is another type of reaction that is shown also by this class. Look at the oxidation. Aldehydes are very easily oxidized. The caminophore is an oxidizing agent. The product will be carboxylic acid. And you see, you know about the Toluene's test for easily oxidized compound like aldehydes. Look at this. This is aldehyde, silver. Now silver mirror test. So aldehydes are oxidized. What is the oxidizing agent? Caminophore. What will be the product? Carboxylic acids. Ketones only oxidize under vigorous conditions, so heat will be required. Besides oxidizing agent, heat will be required. The reaction doesn't proceed at ordinary conditions. Look at this. Caminophore, oxidizing agent along with the heat, and thus the corresponding carboxylic acid is formed. Methyl ketone. Now, this is an example of ketone. This is methyl ketone is formed. Now look at this. The oxygen contain negative charge here, and this one is iodoform test actually. This one is iodoform test. Yellow PBTCHI3 will indicate the presence of such compounds. So this is another type of test which is shown usually by ketone test. This is test for methyl ketone actually. Now second reaction is reduction. The carbonyl compounds are reduced into alcohol. Similarly to hydrocarbons, these two are the major products First one, to alcohol. This is hydrogenation in the presence of nickel or lithium aluminum hydride is used. Sodium borohydride is used for the reduction. These are the conditions required for the reduction of carbonyl into respective alcohol. In case of this catalyst, no acidic condition is required. In this catalyst, acidic condition is required. Look at this compound cyclopentanone, an example of ketone. Platinum, also a catalyst, hydrogenation will give us cyclopentanol. So from ketone, alcohol is formed. Acetopenone, this is acetopenone, sodium borohydride, and acidic condition, 1-pentyl ethanol is formed. Benzaldehyde, known as benzaldehyde. Benzaldehyde is converted, or we can say that benzaldehyde is reduced into benzyl alcohol. Benzyl alcohol. We have three terms: benzyl, benzyl, and there is also another term which is benza. Okay, isobutyraldehyde, lithium aluminum hydride, acidified condition. So isobutyl alcohol are formed. So these are the product of carbonyl compounds. After reduction, alcohols are produced. These are some other reaction. Now, carbonyl compounds can also be reduced into corresponding hydrocarbons. The two well-known examples are Wolff-Kishner reduction and Clemmensen reduction. In Wolff-Kishner reduction, hydrazine are used, basic condition, while in Clemmensen reduction, the condition is acidic and zinc Ag is used. So you have to know the difference between Wolff-Kishner reaction and Clemmensen. In Clemmensen reaction, look at the catalyst involved and look at the condition required. In Wolff-Kishner reaction, this is the catalyst involved reagent and this is the condition required. Basic condition, acidic condition, NH2NH2, hydrazine for Wolff-Kishner reaction, and acidic condition, zinc and Ag for the Clemmensen reduction. Now, this is you can say that, look at this reaction, it is Feldkraft. You know about Feldkraft alkylation and acylation. So this is acylation, lithium aluminum chloride levous acid, then is Cl catalyst, N-pentyl benzene. So it cannot be made by Feldkraft alkylation due to rearrangement of carbocation. This was another type of reaction. You can simply say that this is carbonyl group, then ketone is formed and ketone is converted into, you can see this is Feldkraft alkylation, alkyl group is introduced. Next reaction is addition of cyanide. How cyanohydrine is formed. Now this cyanohydrine further undergo various types of reaction and we can get various products. This is our cyanohydrine. Cyanohydrine have two functional groups plus one additional carbon. Nitriles can be hydrolyzed to carboxylic acid in acid or basic condition. So after look at the mechanism, this is cyano group which will be introduced here. Now in acidic condition, But you have to keep one thing in mind, that addition of cyanide into carbonyl group give us cyanohydrine. That cyanohydrine itself give us carboxylic acid. Next is addition of ammonia. Look at this. Ammonia can be added. This one is NH2G. Now, if it is R, this is imine. Different group can be obtained from the addition of ammonia. That may be imine, hydrazone, and semicarbazone. Also oxime. Oxime are produced semicarbazide and hydrazone. These are possible by the action of carbonyl compounds with amine and amine derivatives. These are amine derivatives. So amine derivatives give us oxime, give us hydrazone. Oxime, what is oxime? Amine is when N double bond C. Oxime when OH is attached to that N double bond C. And this is hydrazone. Next reaction is addition of alcohols. Now, the addition of alcohol give us acetyl or ketyl product. This is acetyl, and this one is ketyl. Look, compare the acetylene with ketyl. You see, O CH3 or ethyl doesn't matter, but here is one hydrogen, here is no hydrogen. This is the best the difference. In between the reactant and product, there is an intermediate step which is called hemiacetal, when which group is attached, and hemiketal. So addition of alcohol will give us first hemiacetal and then acetal, and first hemiketal and then ketal. This is the mechanism for this reaction. Next one is Cannizzaro reaction. A reaction of aldehyde is self-oxidation reaction without alpha hydrogen. Without alpha hydrogen. When there is no alpha hydrogen, alpha mean next the position next to carbonyl. Carbon is here, no alpha hydrogen. These are the products. You have to practice the mechanism for these reactions, for Cannizzaro reaction, and also for Volcanic reaction, Clemmensen reduction, and also for aldol condensation. Next reaction is addition of Grignard reagent. Carbonyl compound react with Grignard reagent and produce alcohol. Now you can see that addition of Grignard reagent give us alcohol. Similarly, with the cyanide, we can obtain carboxylic acid and also OH group. With the reducing agents like lithium aluminum hydride, platinum, nickel, sodium borohydride, we also get alcohol. So, what we understood from the reactivity and from the general reactions of our aldehydes and ketone, we have to keep in mind that due to the polar nature of carbonyl group, These compounds undergo nucleophilic addition reactions. You have to know about nucleophile. What is nucleophile? How the carbon and oxygen bond is polar and polarized. How the addition product will be obtained from the nucleophilic addition reaction. Beside nucleophilic addition reaction, the other reactions are reduction. These are reduced into either alcohol or into alkane hydrocarbons. Next is oxidation reaction. Aldehyde and ketones are oxidized into carboxylic acids. We can say that aldehyde and ketones can be oxidized by using suitable oxidizing agent into carboxylic acid. Aldehyde and ketones can be reduced into alcohol and hydrocarbons. Cyanide can be added to form cyanohydrine. Cyanohydrine are then converted into cyanohydrine contain hydroxyl group which can be converted into carboxylic acid. Ammonia and ammonia derivative give us amine, oxime, hydrazone. Addition of alcohols. Alcohol can be added and Cannizzaro reaction. Addition of Grignard reagent. If you look at the addition of alcohol, you see hemiacetal and hemiketal, and then acetal and ketal. These are produced. So the summary of this lecture is mainly three types of reaction: nucleophilic addition, reduction, oxidation. Nucleophilic addition, addition of alcohol, addition of cyanide, similarly amine and amine derivative, alcohol. Reduction, reduction into alcohol, reduction into hydrocarbon, oxidation, oxidation into carboxylic acid. These are the major reactions that are shown by aldehydes and ketones. There are certain names reaction which are frequently discussed or asked in the exam. So you have to list down some name reactions like Wolff-Fishel reaction, Clemmensen reduction, Cannizzaro reaction, aldol condensation, and also a few other reactions. If you know the mechanism of these reactions, it will be easy for you to understand the different conditions which are involved and the different reagents which are involved in these reactions, and then you will be able to differentiate between these named reactions. So, but just keep in mind that aldehydes and ketones give reduction, and reduction produce alcohol, reduction produce alkane. They also give carboxylic acid by oxidation. Then the nature of aldehyde and ketones is different. So you have to also know that how aldehyde and ketones are differentiated, how they are different in terms of physical properties and in terms of some chemical reactivity, and how they are differentiated, what are different tests for aldehyde and ketones. And then about the nucleophilic addition reaction, what are different types of nucleophilic addition reaction which are shown by aldehydes and ketone. At least you have to know the list and you have to know that's the name and simple the general sketch of this reaction you have to know. I've already asked you to compile a short note of the reaction of aldehyde and ketones and give a sketch how aldehyde and ketones are converted into different compounds, into different products. So starting from aldehyde and ketones, what are aldehyde and ketones? What is mean by carbonyl group? What is the nature of carbonyl group? What are physical properties that are shown by carbonyl group, by aldehyde and ketones? Also, the classes of the carbonyl group, the classes of compound which contain carbonyl group like aldehyde, ketones, carboxylic acid, and then carboxylic acid derivatives. So you start from the introduction, the general definition of carbonyl group, then compounds containing carbonyl groups, then physical property, then coming towards aldehyde and ketones. So physical properties of aldehyde and ketones, the way they are prepared, different procedure, different methods for the preparation of aldehyde and ketones, and then different chemical properties which are shown by aldehydes and ketones. The most important one is nucleophilic addition reaction, reduction, oxidation. Nucleophilic addition, reduction, oxidation. And keep in mind that if you are asked that how alcohols are prepared from aldehyde, so you have to know, and you have to give example, and you have to mention the condition required and the reagent required. And if you are asked that give how aldehydes are converted into alkane, so you have to know about the type of the selection. This is reduction, and what are the conditions which are required for the reduction, and what are the reagents that are required for the reduction, and then how carboxylic acids are produced, are obtained from aldehyde. If you are asked to give the mechanism, so first of all you have to know about the carbonyl group. Look at this, look at the polarity, the polar nature of this group. Look at the electron rich and the electron poor point, and then how the nucleophile will approach, how the reaction will go on. So if you know the polar nature and then the nature of the attacking reagent, so you will be able to understand the mechanism as well. Then it will be easy for you to understand the mechanism. So this was all about the aldehydes and ketones, starting from the general introduction, then classification, then physical properties, then preparation, then chemical properties. While discussing the chemical properties, you have to know what are the major products that are obtained from aldehyde and ketone. Sometimes the question is asked there, starting from aldehyde, how the following compounds are obtained. Starting from aldehyde, starting from ketones, how the following compounds are obtained. And sometimes the question is asking like this. The question is asked like this. The reactant end product is given, and a question mark is given here. And you have been asked that to complete the reaction. It means that you have to put the appropriate reagent and condition required. So if you put H2Ni, it's okay. If you put lithium aluminum hydride, you have to also mention the condition as well. Similarly, sometimes it is asked that is the part you have been given certain reactions, and certain reactions among those reactions, certain reactions are impossible. For example, in ordinary condition, you cannot oxidize ketones into carboxylic acid. So, if you know that this reactant require this condition to be converted into that product, first of all, focus on the nature of the reactant. The electrophilic nucleophilic site, the electron rich electron poor site of the reactant. Then look at the condition, which condition is required. Then the reagent, acidic condition, basic condition, neutral condition. The reagent, that is reducing agent, oxidizing agent, or any other reagent. Beside this, if you make a list of oxidizing agents and a reducing agent, then it will be easy for you These are the reagent, these are oxidizing agents which are used for the oxidation of compound. These are reducing agents which are used for the reduction of compounds. When you know the oxidizing agents and reducing agents, and then focus how the oxidizing agents oxidize a compound, and how are a reducing agent reduce of a compound, the chemistry, the mechanism involved. So okay, thank you very much. This was all about the aldehyde and ketone. In first part, general introduction and preparation in physical properties of aldehyde and ketones. And in the second part, chemical reactivity, the reactions that are shown by aldehydes and ketones, especially nucleophilic addition reaction, reduction, and oxidation. Nucleophilic addition products, reduction products, and oxidation, what will be the product? And for each of these type of reaction, what are the conditions required? So if you are asked that how imines are produced, how imines are formed, you start from the carbonyl compound aldehyde by the action of ammonia, and also ammonia derivative give us enzyme, give us hydrazone, give us carbazide, etc. So these are different compounds which are obtained from the aldehydes and ketones. Thank you.